Okay. So, a group of students set up the experiment below. 2 balloons were filled up with 1 liter of air at 25 degrees Celsius. 1 balloon was then placed into an oven with a temperature of 50 degrees Celsius. So, first thing that we have is to complete the data table. So, 2 balloons were filled up with 1 liter of air at 25 degrees Celsius. So, the starting temperature is going to be 25 degrees Celsius, and the starting volume is 1 liter. 1 balloon was then placed in an oven with a temperature of 50 degrees Celsius, and I don't know what the new volume of that balloon would be. Does it say anything in there at all about pressure? That means that pressure is constant. Every experiment is designed to answer a question. What question were the students investigating? So, we are trying to see what the relationship is between temperature and volume. So, if the temperature of a gas is increased, how will the volume change? So the control and the constants. So let's start out with constants because that's a little bit easier, right? We already know one. We already know that the pressure doesn't change. But we also know that the amount of gas in the balloons is the same, which means that we have the same number of moles. That is constant. Okay, so then the next thing is the control. So listen to me carefully. The control is not what you can quote-unquote control during the experiment. You can control everything in the experiment. That's the point, right? The control is a trial where the independent variable has had no effect. So in this experiment, what are they intentionally changing? What's their independent variable? The temperature. So they're intentionally changing the temperature and measuring the volume. So independent variable is temperature, dependent variable is volume. So the control is a trial without the independent variable, where it has no effect. So that would be the volume of the gas before we heat, before we put it in the oven. So that's my control. It's the volume of the gas before I apply the independent variable, before I heat the gas. So 1 liter, 25 degrees Celsius, that is my control. Last problem says calculate the volume of the balloon after being placed in the oven. So from our data table, we know that pressure is constant. We've got T and V. So if I write my combined gas law, we don't need pressure, so that goes. So I just have V1 over T1 equals V2 over T2. So what do I have to do with the temperatures first and foremost? They're in Celsius. What should they be in? Kelvin. So I got to add 273.15. So this gives me 298.15 Kelvin. And this is going to give me 323.15 Kelvin. So now that my temperature is in the correct units, we're just going to plug and solve. So my volume 1 is 1 liter. My temperature 1 is 298.15 Kelvin. My volume 2, that's what we're solving for, and the temperature is 323.15 Kelvin. So you can cross multiply or multiply both sides. You're going to end up with, whenever we solve, 323.15 divided by 298.15 is going to give me 1.08 liters. So the temperature increased That's a direct relationship. The volume should increase, and it increased a little, so we know that we did this right. Okay. Next one, a sample of gas is at constant volume. If temperature is doubled, what will happen to the pressure? So I've got temperature and pressure. So for T and P, what's the thing to remember? The little phrase. So T and P is the Gay-Lussac's law. So that says that Gay-Lussac directly touches people, which means the relationship is direct. So if the pressure is doubled, if the temperature is doubled, then the pressure is doubled. It increases by 2 times. So that's C. Next one, what will happen to the pressure of the gas if the piston is pushed down? So if I'm pushing down on this piston, what happens to the volume? So if volume is increasing, pressure will, if volume is decreasing, pressure will increase. So is it due to more collisions or less collisions? More collisions. All right, let's look at number 4. The volume of gas is 2 liters at 200 K. What does the Kelvin temperature equal for the volume of the gas to be 4 liters? So we start with a volume of 2 liters and we end at a volume of 4 liters. We started at a temperature of 200 K. So what's happening to the volume here? Doubling. So that means because the relationship between temperature and volume is direct, that means that T2 must be double T1. So the answer is 400 K. Which of the following is true of kinetic theory? So you can think of gas particles, according to kinetic theory, it's like a bunch of highly sugared, excited, blindfolded kids running around the gym. And they have no idea that there are other kids at the gym. They're just running around like fools. So, is that going to be neatly arranged into a lattice structure? No, that doesn't sound like a gym full of crazy kids. Gas particles are in constant random straight line motion. That seems plausible. Gas particles are attracted to each other. There are no attractions according to kinetic theory. No attractions. Gas particles move faster at lower temperatures. That's no good. So the correct answer has to be B. When will a real gas behave like a most like an ideal gas? So again, in an ideal gas, there are no attractions. So if I want there to be no attractions, do I want them close together or far apart? Far apart. If they're so far apart from each other, there's not going to be any interaction between them, right? And do I want strong attracted or weakly attracted? Weakly attracted. Okay. A sample of nitrogen gas is bubbled through water and collected in a container. The pressure of the gas in the container, so now we've got 2 gases in that container. You've got nitrogen gas and water vapor. So the total pressure is the sum. You add them together. What is true when acid and base neutralize each other? So H plus gives us acidity, OH minus gives us basicity. So whenever these are equal, that's pH 7. That's neutral. So the correct answer is C, equal numbers. What is the pH of 0.001 molar HCl? So you can do negative log of that number. And since this is the concentration of HCl, this will give me the pH. So that's going to be 4. As a solution becomes more acidic, H plus ion is responsible for acidity. So more acidic means more H plus ion. Which of these describes why NaOH is a strong base? So anything is strong or weak because of how much it ionizes. A strong acid or base ionizes 100% in solution. Let's look at number 12. Which of the following shows an acid-base neutralization reaction? So for one, you need an acid and you need a base. Acids start with hydrogen, bases end with hydroxide. That's the only one that shows that. You're also going to get a salt, which has no effect on the pH, and water. And the pH of water is 7. So that's neutralization. Number 13 is a titration. So in a titration, you start off knowing the moles of one thing, and you use that to figure out the concentration, molarity of another thing. So first thing that we have initial and final volume. So if I find the difference here, 29 minus 17 is 12. That's 12 milliliters. 17 minus 12 is going to give me 5.00 milliliters. So what do I know more about? HBr or magnesium hydroxide? We know more about HBr, so that's where we start. So my first step is to find the moles of HBr. So I've got that the volume is 12.00 milliliters, and I've got the concentration is 0.36 molar. It tells me that. Molarity is moles over liters. So I know the molarity. I'm looking for moles of HBr. I know the liters of HBr. All I got to do is convert 12 milliliters into liters. So whenever I solve for moles of HBr, I'm going to get 0.36 times this number. So I get 0.00432 moles of HBr. Okay, so I'm trying to figure out the concentration of my MgOH2. So I need moles over liters. I know the liters of my magnesium hydroxide, so I need to find the moles of my magnesium hydroxide. So I know the moles of HBr. I've got a balanced equation, so I can find the moles of magnesium hydroxide. So I start with this many moles of HBr. I want to cancel out mole of HBr, so that goes on bottom. I'm solving for moles of magnesium hydroxide. So in my balanced equation, there is 1 mole of MgOH2 and 2 moles of HBr. So I just got to divide my moles of HBr by 2, and I get 0.00216 moles of magnesium hydroxide. Okay, I've got all the pieces now. I've got moles of magnesium hydroxide. I've got liters of magnesium hydroxide. So I can find the molarity of my magnesium hydroxide. So molarity is equal to moles over liters. 0.00216 moles. 5 milliliters is the same thing as 0.005 liters. So once I do that, I solve and I get 0.432 molar magnesium hydroxide. And that's my final answer. That's what I'm solving for.